All right, so now we're going to get into the shape of a distribution. And again, like I said before, a distribution is a way to visually show how many times a variable takes on a certain value in a data set. So it's just basically a visual way of showing a data set. Now there are, like I said, 3 types of ways we're going to describe it. Now I didn't talk about uniform, but we'll talk about that. We probably won't get too much into uniform. We're going to more focus on symmetric and skewed. So a symmetric distribution could look like any one of these following distributions here. This is where your distribution, your data set, your mean and median are the same, and actually your mode could be the same as well. Now mode is the one that we'll worry about the least. Sometimes the mode won't be the same, but in a perfectly symmetric distribution, your mean, median, and mode would be the same. In a symmetric distribution, as we represent our data visually, it will look like your data has a line of symmetry. So for example, in this first data distribution here, this would be my line of symmetry. And in my second one, this would be my line of symmetry. And in my third one, this would be my line of symmetry. All of these are symmetric distributions. And now perfectly symmetric distributions are very rare. However, approximately symmetric distributions are actually pretty common. It's way more common than a perfectly symmetric data set, but basically an approximately symmetric data set is when your mean and median are fairly close together. It looks kind of like, we actually describe this in the statistics world as a bell curve. So it follows that shape of a bell curve. All right, and that would be more of an approximately symmetric distribution here, because it's not quite perfect, but it is still following that bell curve shape. All right, whereas a skewed data set is when, if I were to draw my curve in here, it would look something like this, where we have this portion here is known as a tail. So we have a tail on this data set, and if my tail is on the right, then we say it's skewed right. Whereas if my data looks like this and my tail's on the left, then we say it is skewed left. All right, so that is, these are examples of what a skewed distribution would look like when we start to graph it and do a visual distribution here. So skewed distributions are when a distribution, it's a distribution where the majority of the values are on one side and there are a few values on the other. So again, I already said that skewed right means that there is a tail on the right, but we would know when something's skewed right if the mean is greater than the median. And most of the time, the mean is going to be greater than the mode, and the median will also be greater than the mode. But that's only most of the time. Sometimes that's not the case. So I'm actually going to do the mode in a different color here. We're going to do it in green to show you that sometimes the mean and the median won't be greater than the mode, but most of the time it will be. And so if we have the mean greater than the mode, that means that we're skewed to the right. All right. Skewed left means that you have a tail on the left. And this would mean that the mean is less than the median. And most of the time it means that the mean and the median are less than the mode. But again, that sometimes that won't happen. All right. But when you have the mean less than the median, that means we are skewed to the left. So the factor that drives the skewness of the data is actually the mean. The mean is really what is driving the data to be skewed. It's not the only thing that's not the only thing that's going to drive it to be skewed. However, the mean is what has the most effect on the skewing process. All right. A distribution where all values are equally likely is called a uniform distribution. This is what your distribution would look like. For example, in a real world type of setting, if we were rolling a die 6 times, and you have the chance of getting 1, 6, 1, 5, 1, 4, 1, 3, 1, 2, and 1, 1. All of these are equally likely to happen. So that would be an example of a uniform distribution. All right. So, outliers. Now, outliers sometimes are what causes your data to be skewed. Not all the time, but sometimes an outlier can cause your data to be skewed. All right. And what an outlier is it is a data point or multiple data points that stick out from the rest of the data. So it's a data point that we kind of question and say, wow, that really didn't fit in with the rest of the data points. It is called an extreme value. We are going to talk more about outliers later, but for right now, what you need to know is that an outlier is something that can sometimes skew the data, and it's something that sticks out from the rest of the data set. So if we look at number 1 and 2, it says, given the following histograms, which these are histograms, these are probably the most common graphs that you have seen already. And we'll learn more about histograms briefly. But given the following histograms, how can we describe the shape of the data, and what do we know about the mean and the median given that shape? All right, so in number 1, the histogram, you can go ahead and draw your bell curve in and follow the shape of the data. Here, it looks like we have a tail that is sticking out on the right side. So what that means is that this data was skewed right. Now we do want to know, then what do we know about the mean compared to the median? Well, remember, if we look at skewed right, that means that your mean is greater than your median. So that's what we're going to write. That's what we know right here. All right. Now number 2 looks somewhat symmetric. I mean, these values here on the outs are exactly the same, and this is pretty close to this here. So this actually follows somewhat of a symmetric bell curve. So this is, we're not going to say it's perfectly symmetric, it's approximately symmetric, which means when you have perfectly symmetric, that means that your mean and median are going to be identical, exactly the same. And in this situation, the mean and the median could be exactly the same, or they can be slightly off. For the purposes of this, we don't know exactly. We're just going to say that the mean and the median are equal to one another. Now, it could be off by maybe 0.0, like maybe the mean is 3 and maybe the median is, maybe the median is 3 and maybe the mean is 3.0005. All right, in that situation, yeah, they're not identical, but they're pretty close. So that's going to be an approximately symmetric type of graph here. All right, but for the purposes of saying symmetric or skewed right or skewed left, we're just going to say the mean and the median are the same.